This video is an intro to using ShopPrentice, a tool for building parametric furniture models in Fusion 360 with the help of an AI agent. Here is what we will go through. First, how ShopPrentice works under the hood. Then, installing it and connecting to Fusion 360. After that, your first build, a dovetailed box. And finally, tips for using the tool effectively. Here is how it works under the hood. You send a request to Claude. That can be a text prompt, but it can also be an image of furniture you want to copy, or a website link. Claude reads the relevant skill files, plans the build, then writes a Python script and sends it to Fusion through MCP. Fusion runs the script and sends the result back. Claude validates the model, fixes any issues, and iterates until the build is complete. The skill files are organized into modular topics, joinery types, furniture types, design styles, and parametric Python templates, plus rules for using the Fusion API correctly, and how to apply wood species and grain alignment. The agent only loads the topics it needs for your specific build, which keeps the context window small. There is also an add-in that runs inside Fusion 360, exposing MCP tools the agent can call. Before installing ShopPrentice, you will need three things: an AI agent. We use Claude Code in this tutorial. Fusion 360, the CAD environment, and Git. There are plenty of tutorials for each of these, so we will not cover them here. Just make sure all three are installed before continuing. To install ShopPrentice, there is only a single command you need to run. Just copy it from the repo and paste it into your terminal. It downloads everything: the skill files, the instructions, and the Fusion 360 add-in, all in one step. After installing the tool, open Fusion. Go to the Utilities tab, click Add-ins. You will find ShopPrentice in the list. Enable it. This will enable the add-in in Fusion. That is all the setup. Let's start the first build. We open Claude Code and Fusion 360, then put in the prompt. Here I typed, let's make a dovetailed box, 12 by 12 by 6, /woodworking. The agent starts building. You will notice it asks for permission to access files. Just approve them for the whole session. The first build takes the longest because the agent is loading all the topic files it needs and making the overall plan. After that, following queries will be a lot faster. The build was pretty complete in one trial because the skill already knows dovetails and boxes well. Now, I am inspecting the result and adjusting parameters like dovetail count and width. The model is fully parametric, so every dimension can be tweaked. Just be aware, this is not a guaranteed model. Even the exact same prompt can generate very different results. And if you are building something new to the skill, you will need a lot more back and forth, like the demo build for the Rubo workbench. This dovetailed box build uses roughly 1 to 2 million tokens, depending on complexity. I use the max plan and have never hit the limit in a full 5-hour session of continuous building. The Pro plan should be enough for casual builds, though that still needs validation from users on that plan. These numbers are based on ShopPrentice version 0.2.0, which includes major token optimizations. If you are on an older version, make sure to upgrade by rerunning the install command. Max plan users can also turn on screenshot validation in the config for visual checks. A few tips to keep usage down. For simple changes like making the box taller, use the parameter editor in Fusion instead of asking the agent. Be aware that the longer a conversation goes, the larger the context window gets, and each round costs more tokens. The agent might still want to see the screen. Feel free to reject it and describe the issue yourself instead. I have learned that humans are way better at finding issues in visual content than LLMs. The skill instructions are already broken into topics, so the agent only loads what it needs. And there is still a lot of room for further optimization in future versions. There are two ways to save your work: as a Fusion document or as a Python script. On the first run, the agent creates a new, empty document. All the following interactions continue on that same document. It will not create a new one every time you ask for changes. This is by design. It prevents the agent from breaking your own documents and lets it self-correct in its own space. You can always save that document in Fusion if you want to keep it. Here's something useful. You can edit the model manually to show the agent what you want. In many cases, the agent picks up your changes and applies them across the model. But this isn't guaranteed. It depends on the type of edit. When in doubt, Describe what you changed and ask the agent to sync. Here is something to keep in mind. You do not always need to save the agent's document. If you are just making a quick edit to show the agent your intent, that is fine. But if you have made a significant amount of changes and you are serious about taking over, that is when you should save. Before the agent reruns a script, you can always ask, "Will this override my document?" You are always in control. A few things you might run into. If the MCP isn't connecting, make sure the add-in is running in Fusion. Fusion crashes are often caused by a bad script. But you won't lose your progress. The script is still saved, so just reopen Fusion and tell the agent to diagnose and fix it. The agent also tends to take shortcuts when writing code for complex designs. For example, using for loops to generate repeated objects instead of rectangular pattern. Models built this way might not be truly parametric. The agent can also use the origin as a reference frame when it should really use existing bodies. And it can make a perfect sketch but at an incorrect direction. Knowing these common issues will help you quickly identify why things break and guide the agent to the right path. If the model doesn't look right, don't just repeat the same prompt. Rephrase your idea in a different way. That gives the agent new information to work with. You can also check the feature timeline to find exactly where the build went wrong and point it out. Keep in mind, the agent is great at writing code, but it's not great at visual judgment or basic physics. Its mistakes can be unexpected, not the kind a human would make. Once you get a feel for how it thinks, guiding it gets much easier. There is a point where you might want to take over. One approach is to use the agent to quickly build a basic model as a starting point, then take over and refine it yourself after a few iterations. The other approach is to let the agent do the full build for something more complex. But that requires a deeper understanding of what the agent can and cannot do, and it costs more tokens. Finally, this is a fast-evolving tool, so there is not a clear answer. It really depends on your use case. That's it. Head to the GitHub repo to get started, and happy building.